In this video, we are going to look at Lewis symbols and the Lewis structures of ionic compounds. We use what is called valence bond theory to predict how two nonmetal atoms will share their electrons within a covalent bond. When we have a covalent bond, so this might be an example of two atoms, in order to get that covalent bond, you have to have this overlapping here, and there must be electrons within that overlap in order to make the covalent bond. Lewis theory simply states that atoms want to look like the noble gases. And when we say look like the noble gases, what we mean is they want to have the same number of electrons. So they're going to gain or lose electrons in order to achieve that stable arrangement. Now, if an atom has the same electron configuration as a noble gas, then the two are isoelectronic. In order to achieve this, we either gain or lose electrons like ions, or we can share electrons, such as in a covalent bond. And we use what is called the octet rule to identify when an atom has achieved that stable electron configuration. So the octet rule simply states that atoms want a total of 8 electrons around them. And that is so that they can look like the noble gases. There is an exception, and the most common that we're going to see in this class is hydrogen. Hydrogen can't fit 8 electrons around it. It's just not big enough. If you recall, it's in group 1 and period 1, so it can only have a maximum of 2 electrons around it. So with hydrogen, we use what is called the duet rule. And the duet rule states that hydrogen likes 2 electrons around it. And it wants to still look like the noble gas, but in this case, it's going to look like helium, which only has 2 electrons. We can use the Lewis symbol. Got to get my colors right. There we go. We can use the Lewis symbol to represent the valence electrons of an element or an atom. So group 1 has 1 valence electron, group 2 has 2, and all the way down to the noble gases, group 8 has 8 valence electrons. To show these valence electrons, we simply just draw the number of valence electrons around the atomic symbol. I also like using the Lewis symbols to show how many bonds each nonmetal likes to have to it. So for example, if we look at the Lewis symbol of carbon, it has 4 valence electrons. So I can draw it as 1, 2, 3, 4 electrons as shown below. Electrons like to be in pairs. They need to be in pairs. And those pairs can be as just electrons or go find a bond. When I draw it like this, it's easy to see how many bonds the atom likes to have. Let's also look at nitrogen, and I'll show you exactly what I mean. With nitrogen, I have 5 valence electrons. So I'm going to start by putting 1 electron on each side, and then I'm going to start doubling up. When I double up, these electrons are in a pair. They're fine. They don't need to go find another one. However, my other three, need to go find another electron in order to be happy. So nitrogen likes three bonds. If we do that same logic with carbon, we can see that carbon likes four bonds. When you are drawing these Lewis symbols, what is very important is don't get caught up on where do I put the dots? How do I do this? Just have your element symbol with the valence electrons shown around it. So if we're dealing with oxygen, this Lewis dot symbol or this Lewis dot symbol, they're the same. It's all good. Either will be accepted. With the second Lewis dot symbol, I can easily tell that oxygen likes two bonds to it. How I have it written in the first one, it's hard to tell how many bonds it likes to it. So that's the only reason I like drawing it as I showed you over here. But as long as you show the number of electrons around the element, you are good to go. Something that we need to remember is in ionic compounds, there is no sharing of electrons. And that's because there is a full transfer of electrons to create the ions, and the positive, negative, attractive forces are what hold those ionic compounds together. However, we can still use these Lewis structures to show the formation of an ionic bond. If you recall, in an ionic bond, your metal is going to lose its valence electrons. So the metal loses its valence electrons to become a cation, while the nonmetal is going to gain. The nonmetal gains valence electrons to become an anion. If we look at an example, let's look at the example of calcium and oxygen. When I draw the Lewis symbol of calcium, calcium is in group 2, so it's going to have two valence electrons. Now, oxygen is in group 6, so it's going to have 6 valence electrons. In order to become a compound, calcium is going to transfer both of its electrons to the oxygen. And in doing so, it now doesn't have any electrons in its valence shell. Now, I know what you might be thinking. Natalia, I thought you said having a full valence shell makes it more stable. Well, if you look at it, this has an empty shell. However, the next one down is completely full. So we can write this as soon as calcium donates its two electrons to oxygen, the Lewis symbol isn't going to have any electrons around it. And I can show, since it lost those two electrons, it's going to have a 2 plus charge. Now, oxygen accepted those two electrons, so it's going to have a total of 8 electrons around it now, which will result in a 2 minus charge. This right here is the Lewis structure of calcium oxide. Calcium oxide is an ionic bond. All right, let's get some practice. Let's do this first one together, and then you can go ahead and try the other ones. The first thing I'm going to do is draw the Lewis symbol of each gun present so I can visualize how they will fit together. When I draw it like this, I can see the sodium is going to transfer its electron to the chlorine, which means I won't have any electrons around it. And since it transferred that one electron, it's going to be a +1 charge. The chlorine gained that one electron, so it's going to have a total of 8 electrons around it. And in doing so, it has a negative charge. So this would be the Lewis structure of sodium chloride. In this next example, we're not dealing with a 1-to-1 mole ratio anymore. So if I look at my magnesium and I have 2 valence electrons, I just am going to draw them on either side like this. And then I can draw in my chlorine. Chlorine has 7 valence electrons. And when I draw it like this, it's easier to see that magnesium is going to transfer 1 electron to one chlorine and the other electron to the other chlorine. So in this case, we get that ionic transfer of electrons from magnesium transferring it to 2 different atoms. So I can draw my magnesium. I don't have any electrons around it, but now I have a 2+ charge. And then I can draw my chlorides. Now, it makes no difference to me if you draw it as I drew it like this, or if you just want to draw your magnesium, and then you can draw your chloride with all of the electrons, and we're going to have 2 of those. Sometimes you might see the 2 written out in front. Either is fine with me for this class. All right, go ahead and try lithium oxide and aluminum sulfide. Pause the video, and then you can come back and we'll do them together. Okay, hopefully you have your answers. When you give the Lewis structure of these ionic compounds, it's totally fine with me if you just give the Lewis structure. Remember, this here is the Lewis structure. This is just a visual of showing how you get your Lewis structure. So with the following 2 for C and D, I'm just going to show the Lewis structure. So I know that lithium is going to lose 1 electron to become positive. Oxygen is going to gain 2 electrons, and in doing so, it's going to be a 2 minus. Then since it gained 2 electrons, that other electron has to come from somewhere, and it is the other lithium. Finally, with this one, we're going to have 3. I'm going to draw the aluminum first. We're going to have 2 of our aluminum, and aluminum is going to lose all of its electrons. It's in group 3, so it has 3 electrons. So it's going to have a 3+ charge. And then we're going to have 3 of my sulfides. So that would be the Lewis symbol for aluminum sulfide.